guys, welcome back to TechDose, and in this video we will look at number of ways to form a target string given us dictionary problem, which is from Leetcode number 1639. Let's now read the problem statement. In this problem you are given a list of strings of the same length, words, and a string target. Your task is to form the target using the given words under the following rules. The target should be formed from left to right. To form the ith character of the target, you can choose the kth character of the jth string in words if target at I is equals to word set jk. That means when you take the jth word and the kth character, it should be equal to the ith character of the target. Once you use the kth character of the jth string of words, you can no longer use the xth character of any string in the words where x is less than equals to k. In other words, all the characters to the left of or at the index k become unusable for every string. Repeat the process until you form the string target. Notice that you can use multiple characters from the same string in words provided the conditions above are met. Return the number of ways to form the target from words. Since the answer can be very large, so we have to take modulo 10 to the power 9 plus 7. Now let's look at the constraint before we look at any example. In this case, the total number of words can be 10 to the power of 3 and each word can be of length 10 to the power of 3. So if you find out the maximum number of characters in words, then that can be maximum 10 to the power of 6. All the string in words have the same length and the target length will also be maximum 10 to the power of 3. So words I and the target contain only lowercase English letters. Now let's look at an example for better understanding. Let's say that we are given 3 words in the words corpus and all of them are of length 4. Okay. Now the target is, let's say, of length 3, which is ABA. We want to find out in how many ways can we form this ABA moving from left to right in the words index and also in the target, right? So if I look at this index number 0, then I have option of choosing A, B and C. We can choose any one and we can choose multiple characters if they are matching. So in this case, I will try to match it with this A. Is it matching with the first A? Yes, it is matching. So now if I choose this A from the first index, that means from the first column, then if I have to match this B, I cannot match it from this column here. Okay, it is not possible according to the rules. So we have to go to the next column. So if I have to match this B, I have to match B from this column. Now we can choose to match this B from this column 1, or we can also match it from column 2 or from column 3. So we have that choice of matching or not matching. But if there is a match, then I will try to match it, right? So if you try out all these possibilities of matching by iterating through each of the character in the given column, and you can check out that A will match. This is the first match. Another match will be this A, B and this A when you skip all the characters in the second column, right? So starting with this A, we formed ABA 2 times by including the B from the first column. Now if I don't include this B from the first column, you can choose this A, B from the second column and this A, or you can go for this A as well. So we have 4 options to make the target starting with this A, right? But then you can say that I will not start at this A, or maybe I will not even start at this column number 0. And you can choose to start at column number 1. And here I have an A. So using this A, you can form AB, A and AB and the other one A, right? So 2 ways by using this A. And even you can say that I will not start at this point and I will start somewhere at index number 2. But you check it out that at index number 2 there is no A. At index number 3 there are 2 A's, but after this, how will you form this BA? It is of insufficient length, right? So for that reason, we were able to form ABA in 6 possible ways by trying out all possibilities, and therefore the all possible ways to form target is 6 in this case. So this is our answer, right? So if we apply the brute force approach, then for this A to be chosen, you can choose any of these characters to be as the starting point. Because what you can do is we will be iterating for all the characters in the column. So I can start with this A and maybe all of them could have been A, right? So I would have tried with all these A's, and maybe I will also say that I will not try with any of these characters in the 0th column. So there is an extra option of excluding everything here, and maybe I will choose a start point at index 1, and maybe I will not choose a start point at index 1 but at index 2, and this will be true for all the characters of the target, isn't it? So for any character we will be looking at all the characters of these words. Okay, so if you have a total of, let's say, m number of words and n is the length of each word, then for each character we will be looking at m into n characters. And so if the length of the target is k, then you can imagine that m into n possibilities will happen for each character, and this will be forming a recursion tree diagram. Therefore we will be forming an exponential complexity of mn raised to the power of k, right? And the space complexity will be order of n, which is for the recursion call stack, and the n value is the number of columns, right? That means the word length. So I hope you have understood the brute force complexity, and definitely this is not going to work in any way. Now let's try to look at a recursion tree diagram for our solution. Okay, so we will be trying out all possibilities, let's say, and we are given these words, and we have 3 words, okay, in the corpus. Each of them are of length 4, and our target is of length 3. So let's see how to solve this problem by recursion. Now if I ask you to solve it by recursion, then what you will do is you will take a t position pointer. Okay, so let's call it tp. The position pointer will be pointing to the character that you want to match. That means position number 0. Let's call this as index. The index will say which column number you are looking at. Okay, so this is, let's say, the node values here are, let's say, the index values. Okay, so the column number of the word corpus. Now if you are at column number 0 and I have to match this a, then how many a's are present? There are 2 a's. So we can have 2 starting points, 0, 0 and 2, 0. So let's go for 0, 0. If I go for 0, 0, I will be matching an a, and I will be going to the next column, because if I have included this a in the match, then I will be going to the next position in the target, and now this b cannot be matched with any of the characters in the same column according to the problem statement, right? So I'll be skipping to the next column, and that is why the index value has become 1 here, and the TP, that means the target position, is equals to 1. Now at this particular point, again I will be iterating for all the characters top down, and I'll be checking is there any b which is matching? Yes, there is a b at 1, 1. So at 1, 1 we have a b match, and which will lead us to column number 2. So this is how we reach to column number 2, and we will be going to the next position. Okay, index number 2. Now at this column number 2, do we have an a match? So there is no a match. So what I will do is, I have no option but to exclude this column and go to the next column, which is 3. So that is why I have not included anything here. I will be going to this 3. Okay, and my position pointer in the target will not change because we have not done any match. So we are at this 3rd column, and at this 3rd column, do we have a? Yes, we have 2 a's. So there are 2 possibilities. So if we take the first possibility at 0, 3, then at 0, 3 we have an a match. So where will be the target position pointer? It will come at index number 3, which is out of bound. Okay, now when the position pointer is out of bound, this will contribute to +1 way, because we have successfully formed the target by following all the rules, isn't it? So it will be doing +1, or it can return +1 in the recursion call. So in the code I will show that it will be returning a 1 value. Okay, now on the other side, if you check, once we return back from the recursion call, because we are out of bound anyway, and our target was also done, right? So we will be trying for any other a, and we have another a at 2, 3. So you check it out that after backtracking, we will be trying the other possibility, include this a at 2, 3. So again, when I backtrack, my position pointer was again at 2, okay, at this index 3. Again, if I match this a, my TP will become index 3, which is out of bound. That means again we have done a match, and successfully it will be adding +1. Okay, so it will be returning 1 as the return value. Fine. So now we have successfully formed 2 matches. Okay, now there is also an option of not including any character of this column. So if you try to not include any character and you were at the 2nd position in the target, then where will you reach? You will reach to the fourth column. So you are out of bound in the word corpus, and you haven't yet matched all the characters of the target because we still have certain characters to be matched, isn't it? So that is why this will return a value 0, because we could not match anything, right? I mean, we could not actually form the target. So what will this 3 return? This 3 will be returning 1 plus 1 plus 0, which will be 2. At this 2, there was actually no option of including the TP equals to 2. That means this A could not have been matched at this 2 because this 2 do not have any A. So what will this return? This will return the addition of include and exclude case. So include case was not possible, so exclude case returned 2. So this will be returning 2. Now at this one, we have tried to include this B. Now there are no other instances of B. So there is another option that maybe I will not include this B, and maybe I will match this B later at some later index at, let's say, index number 2, isn't it? So if I have to match a B at index number 2, then I will not be matching at index number 1. I will be skipping all these 3 characters C, B, A, and therefore my target position being at 1 will remain to be at 1. So when I go to this index number 2, then again my target is to match B. So I will again be iterating through this entire column number 2, and I will be finding each possibility of B. I will be making recursion call. So I found a B at 1, 2. So yes, at 1, 2 there is a B, and therefore my target position will become 2 here because a match has happened. I will go to the next position, and my index will also come to 3. Now at this 3, if you look at this carefully at 3, what we have to do is we have to match this A, okay, and we have this much at our disposal, right? So if you look at it carefully, then this problem and this problem is the same. How this is same? Because if you look at the previous 3, okay, this one. So at this particular point, we had to match everything from position number 2 and after that, and I had all the indices, I mean all the characters at our disposal from index number 3 and after that, right? So this, how many characters I have to match in the target and the number of columns that I have in the word corpus is actually a sub problem, okay? Because if the number of words changes, that means if the column changes, then I mean the characters to be matched will be different, isn't it? So it can give us a different answer. But if the target to be matched and the characters at hand are also same, then they are exactly same sub problem. So in this case, the sub problem definition will be what number of characters do you have to match in the target and what is your index in the word, okay? So I'll take the TP, that means the position, and the index. This will be creating a unique sub problem, okay? So if I have to tell you for this particular example, there are 3 unique positions of the target and there are 4 particular indices. So the total combination of sub problem will be 4 cross 3, which will be 12, okay? Now I need not calculate this entire thing. If I am already saving the answer somewhere using memoization or dynamic programming, then what I will do is I will save it in the index cross T position, and I will be saving it. So I already know that it is 2, right? For this 3 value it will be 2. I mean this 3 comma 2 value, okay? So for 3 comma 2 value, because the index is 3 and the T position is 2, my value will be 2 because I got a return value by calculating it, and therefore we can simply return a 2 here without even having to calculate anything, isn't it? So this is how we will be applying dynamic programming to this recursion, because we have repeating sub problems, isn't it? Now at this 2, at this index number 2, I have another option of not including, I mean not matching this B with anybody at index number 2. So I can delay that match and I can go to index number 3. So if I go to index number 3, the total number of indices are only 4 from 0 to 3, right? But now you have to match 2 characters B and A. For matching 2 characters, at least you need 2 columns, because you cannot match 2 target characters from the same column, isn't it? So, you know, this is insufficient size, right? So if the T position is defining that you have more characters left than the number of columns, then I will say that we do not have sufficient size to match, so don't bother about matching and let's return a value 0 from here, right? Now what will this 2 return? This will return a value 2, which is 2 plus 0. At this one I have tried all possibilities, and what will this return? 2 plus 2, that means it will return 4. So via this A, I had 4 possibilities, and if I can show you, it will be A, B, A, and then A, B, A. And again, if I skip this B at column 1, but I include at column 2, then A, B, A and A, B, A, right? So these are the 4 different possibilities which I got from the left end. Okay, if I match it with this A. Now, if you apply your logic, and if I know that starting with this A, I could form 4 times target. Then if I start with another A in the same column, then how many same targets will I form? Exactly the same, isn't it? I mean, if you think about it carefully, you will get it. Now, if I had another A, then in exactly 4 times target will be matching, isn't it? So, you know, the frequency of this character will be actually helping us to not recalculate the same subproblem. Therefore, what I can do is I can multiply this 4 by the frequency of A, that means 2 times, and I will be getting the total count to be 8, right? Because from here as well I will be getting 4. Even if I match another A at 2, 0, I will still be getting 4. So applying this logic, I have got 8. Now the last option was to not match with any of these characters, right? So if I choose that I will not be matching with any of the characters, then maybe I will be going in future, and let's say at 1, my T position being at 0, I mean here the T position will be equals to 0, right? Because we are not matching here. So if my T position is 0, I am at 1, I will check if there is any A. Yes, we have an A at 2, 1. So we will be matching, and here our T position will be changing. So since the 0th character has matched, this will become 1. Okay, now we will be matching for B. In column number 2, do we have a B? Yes, I have a B at 1, 2. So I'll be matching. So my position pointer will now come at 2. If you look at it carefully, again this is a repeating subproblem, right? Even this might be a repeating subproblem which I don't need to solve. Yes. So this was also a repeating subproblem. Here the TP value was 1 and the index was 2. So it was 2, 1. And this is also subproblem 2, 1. So I could have simply returned the value 2, having recalculated here, repeating subproblem, right? So this is how we will get 2. And on the other hand, if I don't include, I mean if I don't match with any of the characters at 1 for this A, and I try to match it starting with index 2, then I can simply declare that since I have 3 characters to match and I just have 2 columns at my disposal, I will never be able to match 3 characters, and so I will return insufficient size saying 0. Okay, so this will return 2 plus 0, which is 2, and therefore our total ways will be 4 into 2 plus 2, which will be 10 ways. Okay, so the total ways for this example will be 10, and this is the entire recursion tree diagram. I hope you have understood the subproblem definition as well, right? Now calculation will be based on whenever you are in a column position, that means at index, we will be counting all the ways by not matching by any character in that column and by matching by one character in the column. And if you match by one character, you can just multiply by the frequency of that character to get the total match, like how we did last time. We had 2 A's here, right? So we can just calculate for 1 A and I can multiply it with the frequency of A. That is how I calculated it without having to again reparse the tree. And I have to definitely calculate for the non-inclusion case if I don't match with any character, right? And I just have to add these 2 cases. Therefore, the recursion tree diagram will become a binary tree instead of being an n-ary tree. If you look at the previous example, this can be an n-ary tree diagram. Okay, so this is an n-ary tree. But what happens is if I use this concept of frequency, since for any column and at any target position, I just have to match a single character, all these A's will actually not branch out, but it will compress into just a single option, right? All these A's will compress into a single option because I already am applying the concept of frequency. So either you will be matching or you will not be matching, simply like an include exclude case in case of the knapsack type problems. So if you take another example, you try it yourself. If you take this example and you have this target, then you can simply form a binary tree structure very similar to your knapsack type problem, the decision tree diagram. Okay, so if I can just briefly explain you this, how it is made, then our t position is equals to 0 here, right? So t equals to 0, and my index value here will be equals to 0, which is denoted by the node value. So the subproblem, the largest subproblem is 0, 0, where we have all the columns at our disposal. That means every column starting from 0 till the end is at our disposal, and we have to match all the characters of the target. This is the entire problem. Now at this point you already know about the frequency, because I will be pre-calculating the frequency of characters at every index. So the frequency of character at index 0, I mean the A's frequency is 3 times, right? So I will just be branching out 1 time for A. So if I have to match A, I will be matching it, but whatever count I get, I will be just multiplying it by 3. Okay. Now at 1, do I have a B? Yes, I have B 2 times. So let's say I will be matching B, and whatever is the return, I will be multiplying it by 2 times. Now the next thing I have to match it with A. So the T is 2. And now at this index 2, do I have an A? I don't have an A. So that is why matching is not possible. So I will try not to match with any of this character and go to this 3. So when you are at 3 and you have to match this A, count the frequency of A. Frequency of A is 2. So whatever return I get, I will be multiplying it by 2 times. Okay. So when I match, I will be going out of bounds. So that means the target has finished and we have successfully formed a target. So this will be returning a value 1. So when it returns a value 1, we will be multiplying it by 2 because the frequency was 2. So this will be returning a value 2. But then before returning, it will also try not to match it and then match with some later column. But then there is no later column, right? So when you go out of bound in the words, then your target is still at 2. We have not finished the target, and that is why this will be returning a value 0. Okay. So what I will do is I will calculate 2 times of 1 plus 0, as I had already explained you here. Ways by not matching plus the ways by matching multiplied by the frequency of the matched character. So the frequency of A, which is 2, multiplied by the returned value by matching A, which is 1. So that becomes 2, and by not matching you are getting 0. So this is getting 2, and now this will be returning 2, right? So at this point, what we will be doing, there was no match. Okay, so this will be returning 2. Now at this one, we will have a value of 2 into 2. That means 4 plus. If you do not match at this point, then I will go to the second column and I want to match this B. Now if I have to match at index T, the target position number 1, which is B, then at this 2, I have the frequency of B to be 2. So I'll be multiplying with 2 whatever I get as the return value. And if I match, I will be going to the next T position where T position will be 2, right? So at 3 and 2, this is a repeating sub problem, and this already had an answer 2. So this will be returning 2 and 2 will be multiplied. So this will become 4. Now by not including it, if you exclude the second index and go to the third, then you still have 2 characters to be matched because the T is 1, right? And you just have 1 column. So you have insufficient size, and so this will return a value 0. So what this will be returning? This will return 4. So at this point 1, we had 4, which is 2 into 2 from the left side and 4 from the right side. So this will return 8. Now 8 will be multiplied with 3 and this becomes 24, right? So by including the count here is 24. By not including, if you don't match with anyone at index 0 and go to index 1 and your T position is still 0, then there is no A here. So we cannot match with A, and therefore I have no option but to skip. And if you go to this index 2, then you know that you just have 2 columns left, but you have to match 3 characters. Therefore we have insufficient size. So this will return 0 and this will return 0. So 0 will be added, and so this will return 24. Okay. So I hope you have understood how we did the compression in the recursion tree. And if you use this compressed structure, then the total size of this recursion tree diagram will be 2 to the power of n. Okay. If you do not use dynamic programming. But if you use dynamic programming, it will be in the order of n square or similar. So the sub problem here was the index in the word and the T position. So if I consider that n to be the length of the word and k to be the length of the target, then the number of sub problems is nk, and therefore the time complexity will be nk as well as the space complexity will be nk, right? So I hope you were able to understand this entire problem. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, I am initializing a long hash define with a shorter name LL, and I am taking a memoization, that means the DP table, for storing the sub problems. So the first value is the index and the second value is actually the T position, the target position. We know from the constraint that the index and T position can be maximum 10 to the power of 3, and hence I have taken 10 to the power 3 plus 1. The mod value was 10 to the power of 9 plus 7, and we have taken target size, word size, and the number of words, along with counting the character frequency for each of the column, right? So every character has to be counted from A to Z. Now if I have to see the main function, that means the number of ways, we are given all the words and the target. So I'll be assigning the target size, word size, number of words, and calculating the frequency of each of the character from small a to small z for every column. How many columns do I have? It will be defined by the word size, because all the words are of the same size, isn't it? Now I'll be calculating the character frequency using this loop by iterating through all the rows and all the columns. After doing that, I will be setting the memoization table, that means the DP table, with -1 value, because the count of ways cannot be less than 0. It is not possible. Therefore, I am assigning it with an impossible answer, right? You can assign it with any impossible answer. Now let's see the count ways function. So I have already written it above. In this count ways function, we are given the words with the index that we are looking at, and in the index we will be matching each and every character from the words. Then we will be looking at the target and the T position. So if the T position has reached the target size, that means we have matched the entire target, and we have to return a 1 value. Otherwise, if the index has reached to the end without the target position reaching to the end, then that means a match has not happened, and I'll be returning 0. And this is the case for insufficient size. That means if we have less number of columns than the target characters to be matched. Okay. So in both these cases, I'll be returning 0. If the sub problem has been already calculated, then I'll be just returning it without having to recalculate. And if it has to be calculated, I'll be taking what character I have to form, and I will be trying the two ways. The first way is by not matching how many ways can I actually form the target, and by matching how many ways I can actually form the target. So you know that if the frequency of, let's say I was trying to match A is equals to 2, and if there were 4 ways to match with this A and then form the target, then you will have to multiply it by the frequency, because I have 2 choices of A, right? So that is what I am doing here, multiplying by the frequency. And by not matching, there is only one way. Therefore, I am just adding it, and I will have to always take the mod so that it does not go beyond the expected size. And at the end, while returning the answer, I will be writing it in the sub problem, so that if this sub problem occurs again, then I will not have to recalculate it. So this is the entire solution, and I hope you were able to understand it. If you still have any doubt, then feel free to comment below, and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of this programming videos. See you guys in the next video. Thank you.